Hello students, myself Mohammad Wasim, Assistant Professor in Mathematics, Art Science, Commerce College, Gurgaon. In previous lecture, we have studied about Laplace transform. Laplace transform in which we have studied about the definition of Laplace transform. We have seen that if f of t be real valued function, such that f of t is equals to 0 whenever t is less than 0, then Laplace transform of f of t is denoted by Laplace transform of f of t and defined as Laplace transform of f of t integration from 0 to infinity e raised to minus st f of t dt. Correct? We have seen this definition in previous lecture, in which we have seen that the function f of t is a real valued function which is always 0 whenever t is less than 0, and notation for Laplace transform of f of t is denoted by Laplace transform of f of t, and it is defined as integration from 0 to infinity e raised to minus st f of t dt. After this, we have seen that some basic example in which we have found the Laplace transform of 1, in which we get 1 upon s, where s is greater than 0. Then we have seen that Laplace transform of t raised to n, in which we get n factorial s raised to n plus 1, again s is greater than 0. Then we have seen that Laplace transform of e raised to at, and we get s minus a, where s is greater than. After that, we have seen about the properties of Laplace transform, in which we have seen the linearity property, Laplace transform of a1 f1 of t plus a2 f2 of t is equals to taking a1 outside, Laplace transform of f1 of t plus a2 Laplace transform of f2 of t. Correct? After that, we have seen about first shifting theorem. This is linearity property. Second one is first shifting theorem, or first translation. First translation, in which we have seen that Laplace transform of e raised to at f of t is equals to capital of S minus a. In previous lecture we have seen so many things which we have recap all these things. Now in today's lecture we will start with second shifting theorem, and the second shifting theorem is stated as, before going to start second shifting theorem we must know about the remark about first shifting theorem. If we want to calculate Laplace transform of e raised to minus at into f of t dt, we will get capital F of s plus a. Now the second shifting theorem in which Laplace transform of f of t, we can write it as second shifting theorem, in which we can write it as, if Laplace transform of f of t is equal to f of s, then g of t is equal to f of t minus a whenever t is greater than that, and whenever t is less than a. Then Laplace transform of g of t is equal to e raised to minus as f of s. Correct? In second shifting theorem, if Laplace transform of f of t is equal to f of s as given in the definition, then the function g of t is given as g of t is equal to f of t minus a whenever t is greater than a, and 0 whenever t is less than a. Then Laplace transform of g of t is equal to e raised to minus as f of s. Now says as given proof of the theorem, since we know that Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st f of t dt. Correct? Now we are going to replace this f of t with respect to g of t. Replace, then we will get g of t integration from 0 to infinity e raised to minus st g of t dt. Clear? We just put g of t in the definition of Laplace transform. Now since the function g of t is defined in two different intervals, whenever t is less than a, the value of g of t is 0, and whenever t is greater than a, the value of t minus a is f of t, g of t is f of t minus a. So since g of t is defined in two different intervals, we have to break this integration into two intervals such that we can put the values of gt in such interval. So we can break integral from 0 to a e raised to minus st g of t dt plus a to infinity e raised to minus st g of t dt. Correct? Now, in this interval, in the first interval, integration from 0 to a, the value of g of t is 0. As given in the statement of second shifting theorem, g of t is equals to 0 whenever t is less than a, and t varies from 0 to a. So, value of t is less than a means we can put integration from 0 to a e raised to minus st into 0 dt. Similarly, whenever t is greater than a, value of g of t is equals to f of t minus a. So we can write it as integration from a to infinity e raised to minus st g of t is equals to f of t minus a. Okay. Correct? Now, after multiplying e raised to minus st into 0, we will get result 0. So, we can simplify this last equation by 0 plus integration from a to infinity e raised to minus st f of t minus a dt. Now, here integration is from a to infinity e raised to minus st f of t minus a dt. Now, put t minus a is equals to x. This implies that t is equals to x plus a, correct? And dt is equals to dx. Now, for limits of integration, when t is equals to a, x is equals to t minus t, which is equals to 0, and when t is equals to infinity, x becomes infinity minus a is equals to 0, or we can write it a minus a, and we will get infinity minus a is equals to infinity. So, this integration becomes integration from 0 to infinity e raised to minus the value of t is s into x plus a, correct? X plus a into f of t minus a. F of t minus a, we have replaced t minus a with respect to x, and differentiation of dt is equals to becomes dx. So we can simplify this equation as follows: integration from 0 to infinity, we can write here equal to e raised to minus sx into e raised to sa f of x dx. Since e raised to sa is constant term, because the integration is with respect to x, so we can take it outside e raised to sa, integration from 0 to infinity e raised to minus sx f of x dx, and it becomes e raised to sa Laplace transform of f of x e raised to sa, and x is Laplace transform of x. X is t minus a, so we can write it as e raised to sa f of s minus a. Hence, we have proved the theorem of second shifting theorem. Sorry, we will have f of x, and we can write it as t also. So we will get f of s only. Correct? So it is the second shifting theorem for Laplace transform. Now we can see Laplace transform of. Now we can see Laplace transform of unit step function. Now let's see what is the Laplace transform of unit step function. I think we must remember Laplace transform of 1 is equal to 1 upon s. Laplace transform of t raised to n is n factorial upon s raised to n plus 1. Laplace transform of e raised to at, which is equal to 1 upon s minus a. Then Laplace transform of f1 plus f2 is equals to Laplace transform of f1 plus Laplace transform of f2. Then we have the Laplace transform of e raised to Laplace transform of e raised to at f of t, e raised to at f of t is equals to f of s minus a. Then Laplace transform of e raised to minus at f of t, we will get f of s plus a. Now Laplace transform of or second shifting in second shifting, what we have seen? We have seen that e raised to minus as f of s. These are important forms of particular functions which we will use in future for solving examples. Now we will see theorem about unit step function. The theorem is as follows. If Laplace transform of f of t is equals to f of s, which is equals to integration from 0 to infinity e raised to minus st f of t dt. Correct? You have to remember the definition of and formula of Laplace transform first, and then Laplace transform of f of t minus a into h of t minus a is equals to integration e raised to minus s f of s. Now, since we know that Laplace transform of f of t t minus a, h of t minus a have to calculate. Now we know that h of t unit function is equals to 1 if and only if t is greater than 0, and 0 if and only if t is less than 0. Graphically, if we want to produce the graph of unit function, there is a 0, 0, x plane, x-axis, and this y-axis. Correct? Now, up to minus infinity to 0, the value of h of t is this one. And after x running from 0 to infinity, we get the value such as given in the graph. It is the graphical representation of h of t. Now we will try to find the Laplace transform of this function f of t minus a, h of t minus a, integration from 0 to infinity, e raised to minus st, f of t minus a, h of t minus a dt. Correct? Now replace t minus a is equals to u or x, whatever you want to put. Replace t minus a is equals to u. We will get t is equals to a plus u. When we put, whenever t is equals to 0, implies that t is equals to minus a. Correct? And when t is equals to infinity, this one, this implies that infinity minus a is again infinity. And if we differentiate t with respect to u, we will get dt du. Correct? Now let us see what will be our function becomes after substituting. So we will get integration from 0 to infinity of it is integration from first limit is minus a to infinity. Now e raised to minus s, t becomes a plus u. Correct? Then f of t minus a means f of u into d hu and du. Correct? Now we will break this integration into two different integration, that is minus a to 0 e raised to minus s a plus u f of u h of u du plus integration from 0 to infinity e raised to minus s a plus u f of u h of u du. Correct? Now we have replaced all the things which we have considered and want to replace. Now since we know that in unit function h of t is equal to 0 whatever t is in negative, so this integration shows negative value of u, so we can write it as 0 because h of u becomes 0, and after multiplication to this integrand we will get 0, and plus integration from 0 to infinity, e raised to minus s, minus s bracket a plus u f of u du, f of u h of u du, f of u h of u du, correct? And we know that whenever the t is greater than 0, then value of h of u is equal to 1. So we get integration from 0 to infinity, e raised to s a plus u f of u, correct? And integration from 0 to infinity, e raised to minus s a and minus s u f of u du. So we can take minus s a integration e raised to minus s a outside as, and it will become integration from 0 to infinity as s u f of u du. So we will get e raised to minus s a f of x. Here we have printing mistake. We can write it as e raised to minus as f of s. So in this lecture we have studied about second shifting theorem, and we have seen that how to calculate Laplace transform of unit function. In next lecture we will try to find some more theorems on Laplace transform. So please keep watching these videos and try to like it, and always be with us. Till then, thank you. Bye.